Hello and welcome. My name is Xander. I will be your instructor through this tutorial. Now, this tutorial is actually part of a whole course which you can access the first stages for free here on YouTube. Now, in this tutorial, I might mention resources and other tutorials. Do check out the link in the video description, which will take you to the playlist, and also there will be a link to the resources so that you can access and follow along here on YouTube. Now, if you like this course, you found it useful, and you want to take that next step, you can find this course over at Udemy. All the links to the resources can be found in the video description. Now, don't forget, also subscribe to the channel for weekly promotions, discounts, and free course giveaways. At this point, we have created our tables, and we have included all of the field types except the foreign keys, the relationship fields, and primary keys. So now we move into the world of column constraints or field attributes. In the world of PostgreSQL and relational databases, constraints and field attributes are used to define the properties or rules applied to the column fields of the table. Now, much of this is going to be dependent upon your business logic, how you want data to be stored in your database, what it's going to be used for, the context of that data. So it's going to be somewhat impossible to create something that is one fit, one size for all. So let's just define these constraints that we're going to create as rules. We want to define a set of rules to ensure that our data is stored and managed correctly within our tables. For each of our tables, we might create a data dictionary, which is a centralized repository or collection of metadata that describes the structure of the database and its objects. This essentially contains much more information than you would find in the ERD diagram. Here you can see that we have identified columns, data types, constraints, relationships, and other key elements. And this is going to help us design and build and maintain all of our tables. So this is just for the category table. You may build one for other tables. So here you can see the field types. So we're familiar with the field types and the data types, and we haven't discussed keys yet. So in this tutorial, we're going to discuss null. Null represents the absence of a value or an unknown value in a field, column, or table. So we want to ensure that when we insert data into our table, that the correct data has been inserted. There may be some instances where we have fields where the data is going to be optional. So let's just take a look in this category table here. We need to ask ourselves, is this name field optional when we insert data into the category database table? And the answer to that is no, it can't be optional, because if it were optional, we would have a category stored in the category table and we don't actually have a name for it. So it'd be pretty useless. So we want to make sure that we have assigned the null to the fields where we expect data to be inserted when we insert a new record into the category table. So here you can see that although we haven't discussed this, the primary key is false. The parent is true, which means that when we insert data into this category table, we don't necessarily need to include data into the parent field. But you can see the other fields do require data to be inserted in order to successfully insert into this table. Now, you will find this data dictionary to the right of the ERD diagram if you haven't already found it. And this is just an example. It doesn't necessarily represent what we're going to build, but just is a visual aid for you to think about maybe developing your own data dictionaries and for us to utilize in this design process. Right, so what's important here is that we know that in PostgreSQL, the default behavior is that null values will be accepted. So if you don't provide a value for a column when inserting data, PostgreSQL will automatically set the column value to null. Now, that doesn't apply for some special columns like primary keys, but for the majority of the fields that we've created thus far, that will be the case. Now, as we have already created some tables, we can inspect the table once again. So let's just go for, let's go for the products table. So here, if I zoom out, or actually if I do that, you can now see not only we have the column and the type, on the right hand side here, you can see we have nullable. Now, in actual fact, there is nothing inside of the nullable stated for each column here. And that tells me that each field here is going to be optional. When we insert into this table, we won't need to include any of this data. Now you can see in the design, all the fields here, oh, actually it's the wrong table, but let's go back. Let's do the category table. The category table, thank you. So you can see in the category table, it's the same for the category table. So nullable has not been set. So all these fields are set to nullable true at this point. But you can see here in our design, we want to set them all to false. So let's do that. Now, interestingly, taking a look at the category table here, we seem to have this rogue column called category ID. So this would probably be a good time to try and remember how to remove columns from a table. So let's see if we can give this a go. So remember, the first step is to identify the table we want to change. In this case, alter table category. We don't need a comma there or multi-line. We can do this all in one line. And then we want to drop remember to drop the column and then specify the name. So in this case, it's going to be category ID. So let's just double check that. And there we go. So notice that we didn't, in that case, we didn't specify the semicolon at the end. It's so common for students to forget that. And you can see we are now still in this multi-line setup. Now, because I didn't add anything to the end of category ID, we should still be able to use the semicolon. And you can see the table has been altered. And we can now go ahead and see that that has been updated. So we have two options here. We can drop not null, and then we can add not null to fields. So to drop not null, we would need to use the command alter column and the name of the column, and then drop not null. So that's how we're going to append to remove whenever we've assigned not null to any field and we want to move back to null to allow null values. Now, of course, in our scenario, that isn't the case. We want to actually set. So we're going to use the command set not null. So let's run this. So this should be usable as a copy and paste. And that alters the table. So let's have a look at the category. And we can now see that we've changed all the fields that we've specified to not null. So that means that when we insert any data into this table, we have to specify data for all of these fields. Right, so what we're going to learn later on in this course is how to insert data into a database. But let's just use this statement for now, because this is going to insert into the category table and just showcase what we've just done. Now remember, in our category table, we have 4 fields. All fields are required for us to insert data in order to insert data into that table. Now here we're only specifying 3 of them. So this should in actual fact fail because of the null statements or null properties we've just added to all the fields. So if we try and paste that in and try and insert, we're told here that null value in column is active. So we didn't actually insert anything or specify anything for is active, which means we violate the not null constraint that we've included for this table. If you want to insert some data, we're going to need to make sure that we specify can't do that. So if we want to insert data, we're going to need to specify all the fields. Now again, I realize we've not covered this yet, but let's just see this in action. So here we have is active. So let's specify true at the end here. So let's try and insert that. And you can see this time something was inserted. And of course, you probably already realized that works because we have specified data for all of the fields that are required when we insert into the category table. Now that's the foundation of setting null and not null fields. There are a few other points which I think is better introduced once we start to actually query the database. So it's entirely up to you at this point whether you want to work through each table and add the null or not null to different fields. I'm not going to do that in this case. When we create the final table statements at the end of this module, I will include some additional information regarding null or not null values. But for now, hopefully you understand the principles. That's the main point, and how to use SQL to actually make those changes. We've learned in this tutorial that by default, PostgreSQL columns are nullable. There are some exceptions, including primary keys. So this means that if you don't provide a value during an insert operation, the column will be set to null unless it is explicitly defined as not null. So we have learned in this tutorial how to define fields or assign fields to null and not null. Now remember, setting a column to null or not null is important because it defines the behavior, the integrity of the data in your database. So not null, or by defining the column as not null, you're ensuring that every row in a table must have a value for that field. This enforces data integrity by preventing incomplete data. This can also have an effect on your application's logic and help you optimize query performance based upon your needs for specific fields. So it is a crucial decision that you need to take when designing the structure of your database to ensure it aligns with the requirements of your application and your business logic.